If you open your books with me to page 179 in your Algebra 2 book, the title of the lesson is Using Prime Factorization. And our goal is to get to the greatest common factor or the least common multiple, whatever the lesson is asking for or whatever the number is asking for. So what the book shares with us in example 1 is that old methodology of how to prime factor something. So let's look at this over really quick. I'm going to make a real quick example of this. Example 1. Factoring by primes, the way they show it in there is by doing what they call the factor tree. I happen to prefer the division by prime method, which is to take the prime numbers and divide them into the number in question until you get down to a quotient of 1. So 936, for example, is divisible by 2 and results in a quotient of 468. Since it's still even, it is still divisible by 2, results in a quotient of 234. Again, still even, results in a quotient of 117. Now we no longer have an even, so we can't divide it by 2 anymore, but we can divide it by 3. 3 gives us a quotient of 39, which is still divisible by 3, which gives us a quotient of 13. 13 is a prime itself, so 13 and 1. So the prime factorization of this number is 2 times 2 times 2, which is 2 cubed, times 3 squared, times 13. Okay, just to remind you how to do that. That's the prime factorization of the number 936. Now, the point in reminding you how to do the prime factoring is so that you're able to find the greatest common factor and the least common multiple of a pair of numbers. Now, I have a technique that I think is much easier than the book method, but I am going to go over the book method with you, and then I'll show you the alternative method that you can use. Example 2 says, find the greatest common factor and the least common multiple of these three numbers, 72, 108, and 126. The book method has us prime factoring them. So I'm going to do my division by primes. This indeed is divisible by 2, which gives us 36. Still divisible by 2. Again by 2. But now no longer by 2, is divisible by 3. There's my quotient of 1. So the prime factorization of 72 is 2 cubed, 3 squared. Same technique for 108. Lucky that breaks down to 54. 2, 27. It's no longer divisible by 2, but it is divisible by 3. So we're going to go 3, 9, 3, 3, 3, 1. So the prime factorization of 108 is 2 squared, 3 cubed. That should be a cubed. Finally, 126, 2 and 63. Up, no longer is this number divisible by 2. It's already an odd. So we can go ahead and start with 3's. 3 and 21, 3 and 7. 7's not divisible by 3, but it is divisible by 7, which is a prime. So the prime factorization of 126 is 2 times 3 squared times 7. Now, greatest common factor is what is shared. Okay? So, they all have a factor of 2, but only this one has 2 cubed. This one and this one both have 2 squared, because automatically this one has 2 squared if it has 2 cubed. But what is shared is a factor of 2 to the first. This one is 2 to the first. This one is 2 squared, so it has 2 to the first in there. And this one is 2 cubed, so it has 2 to the first in there, which means they all share a factor of 2. Let's look at the 3's. We've got 3 squared and 3 cubed. Well, that means what is shared is the smaller of the two, 3 squared, because 3 cubed automatically has a 3 squared in it. 3 squared. This is the only one with a 7 in it. Therefore, it's not shared. Therefore, the greatest common factor of these three numbers is 2 times 3 squared, which is 18. Least common multiple is the largest power of any present that's there, exists, factor. Largest power of any present factor. So they all share a 2. We've already agreed to that. 2, 2, 2. The largest power is cubed. They've all got a 3 in it. The largest power is 3 cubed. But any present includes that 7 because it is present in this one, even though it's not in the others. So the 7 gets thrown in. Therefore, the least common multiple is 2 cubed times 3 cubed times 7, which is 1,512. Okay? 1,512. Let's do a couple more of these, and then I'll show you the alternate methodology that I have for you. Example 3. Example 3 says, greatest common factor and least common multiple of 48u squared v squared and 60u v cubed w. Let's just divide the numbers for now. Each of these is divisible by 2. This gives me 24 and 30. Both of these are still divisible by 2, which gives me 12 and 15. Still divisible by 2 over here, which gives me a 6. This one's divisible by 3, which gives me a 5. Still divisible by 2 here, which gives me a 3. 3 and 1. 5 and 1. Okay, so the numeric, the constant portion, the coefficient, of these are prime factored with 2 to the 4th times 3. And I'm just going to bring these down, u squared, v squared, as they sit. And I'll explain that in a minute. For this item here, we've got 2 squared, 3, 5, u, v cubed, w. Okay? Greatest common factor is what's shared. They both share a 2, but what is shared is the smaller exponent. Because this one has 4, this one has 2. So automatically this one has an exponent of 2 within it. If I broke it out to 2, 2 and 2, 2, it's the same as 2, 4. So that gives me 2 squared. In the 3's, they both share a 1. They don't share the 5. In the u's, u2, u1, they both share the u1. In the v's, v2, v3, they both share the v2. In the w's, w's aren't shared. Therefore, the greatest common factor is 12 u v squared. Least common multiple is the max power of any factor that appears in either list. So the 2 appears in both lists, but the max power is 4. The 3 appears in both lists, but the max power is 1. The 5 appears not in both lists, but remember the rule is appears in either list. If it's in both, you choose the max power. The u's are in both lists, which means we pick the max power. The v's are in both lists, which means we pick the max power. And the w appears. Okay? So you end up with 2 to the 4th times 3 times 5 u squared v cubed w, which is 240 u squared v cubed w as your least common multiple. Okay, so that is the technique that the book teaches. Now, there is an alternative way of doing this, but there are some places where you can have a mistake that can occur. Now, one thing I want to draw your attention to, on the middle of page 180, on the middle of page 180, I want you to take a look at that, and it says, even if you have a numerical coefficient of a number that is negative. So let's say this is negative, okay? The least common multiple still is going to be a positive number, okay? I want to make sure I'm clear on that. It's still going to be a positive number because no matter what, that negative, or the positive one, remember I'm just pretending this one's negative. The positive one, if you list its normal multiples, 60 times 1, 60 times 2, this can never be multiplied by a normal list of multiples, times 1, times 2, and create a negative number. Therefore, the multiple, the least common multiple, has to be positive. Okay? It has to be positive. The alternative method that I want to share with you, really quick, I want to look at, we'll look at example 21 in the oral. This is oral example 21. We're going to go with listing out the numbers, kind of in a line fashion. X, Y, Z squared. Last one, 20. X, Y squared. So this is number 21 in the oral. And we are going to draw a big division box under the entire thing. And instead of prime factoring, we are going to identify factors that any of these share, whether it's prime or not. The largest one is preferable, okay? The largest one is preferable. That way you get through this the most quickly. I can see right now that these three numbers do indeed share a 5. As far as the letters are concerned, they do share an X, and they all do share a Y. Okay? So now that I've divided this out, I'm going to write the quotient of each of the three. 3x is the quotient of this divided by that. This one over here, negative 5z squared is the quotient of dividing this by that. And finally, 4y is the quotient of dividing 20xy squared by 5xy. Okay? Now, look at the bottom level of quotients. If they are all three divisible by anything else, divide it again. Since they are not, what is left on the left is the greatest common factor. Okay? Now, they don't share anything, the three of these. But here's the tricky question. Do two of these share anything? No, they do not. Therefore, the product of all of these items is the least common multiple. 5xy times 3x times, remember, we have to disregard that negative, as I mentioned previously, because the least common multiple cannot be negative. Okay, after you multiply that whole mess, you should have 5 times 5, which is 25, 25 times 4, which is 100, 100 times 3, which is 300 as your coefficient, xx. So you come up with x squared, y squared, z squared. Okay? There's your least common multiple.